Hello, everyone, and welcome to the Masters of Technology Happy Hour, where once a week I have a drink with someone I meet in the course of business, but someone I'd like to get to know better as a person. Steve Benisi is CEO and founder of FM Technologies. He's also an office mate, so he's right down the hallway from me. Steve runs a company that does filtration, a fluid separation. Hi, Steve. Welcome to the show. You're not in the office.
No. Oh God,
Okay.
no. This is an office at home, and there's a shop here. There's actually a couple properties here, and there's a shop, and some of the world's most advanced technological developments happen right here in Nevada.
Is that right? Is
Yes.
that right? Do your neighbors know how famous you are?
Occasionally they remind me, but somewhat rare.
When one of your filtration units blows up or something?
No, when we're isolating hydrogen, sometimes we have a little noise, let's say.
Oh, okay, okay. So I should tell everybody that Steve and I were office neighbors and also close to neighbors who both live in Nevada. Steve has a considerable amount of patents. Tell us how many.
Starting in 1989, I even have a presentation. You don't need to see that, but if you'd like to, I'd make a real fast run through and show you.
Would you? Go ahead.
This is just a very brief PowerPoint. We're introducing UVF technology. UVF is universal vacuum filter. It's completely new technology. New technology. So that's the technology is used for separating solids from liquids, filtration. And this presentation happens to be from Quorum, which is a conference in Quebec, Canada. To tell you a bit about the background of FM technologies and what UVF vacuum disc filter technology is and how is it different, the key advantages, and then it's going to show installation of a UVF unit. It's UVF, it stands for Universal Vacuum Filters, and they separate liquids from solids, and they're the most cost-effective and the newest technology in the world. Let's begin. I'm going to give you a background, what UVF vacuum filters are and why it's different, the key advantages, and then installation photos and details of a UVF installation. In 1989, I developed the world's most effective pressure filter. Its name was Pneumopress. Pneumopress, a pressure filter. And it's used in chemicals, minerals, pharmaceuticals, food, and it's all over the world. It's in roughly 50 countries now.
You graduated in 73 from Cal State, Chico.
Yes.
And you have a degree in, it says graduate metallurgical and residential architecture. I'm not even aware of
that. That was graduate study. After I got my bachelor's degree, degree was in industrial engineering. Then I studied graduate studies in metallurgy and architecture.
Metallurgy and architecture are two different things, right? So
yes, they sure are.
How did you manage to combine those two things?
Basically, I wanted to build my own home out in the country and have it unique, conceived and designed by me. So I did this in conjunction with the graduate work in architecture. That's how I ended up with a home way up in a little place called Manton.
Manton? Where's that?
It's in a valley below Mount Lassen in Northeast California.
Oh, okay. Now that's your home. You built it with your own hands.
Yes.
Really?
Yes, I built it with my own hands, all by myself out in the country.
You still have it?
Oh, no.
Okay.
I can't even remember which year.
Oh, okay.
Yeah.
That was your home before You moved to Nevada?
Well, I moved to Novato in 1992, 91,
Oh, okay.
1992, something
Okay.
like that.
Got it. Got it.
Yeah.
Okay. Thanks for that background. Now back to FM technology. So that was your own company. Numa Press was the name of the company and the product. And you sold that then to FL Smith. Am I saying that right?
Yes, FL Smith is an enormous OEM engineering corporation, and they were very interested and came after us, especially. I suppose these big companies, they lose sales. I think that's what really occurs. They lose sales and they take notice. And of course, it was a very big sale, and I became a president of one of the presidents of FL Schmidt,
Okay.
and I was president of filtration, of course. And so that gives you a background before that. That's from the pressure filter.
Got it. Got it. Okay. I thought maybe they made you president on the strength of the acquisition that you came in and said that you were.
Yes, they purchased. It's in the public domain. It was an $18 million purchase by FL Schmidt. They purchased roughly 18 or 20 patents of my patents, and I worked with the group for a few years, and so that it gives you a background of FL Schmidt. And then I left FL Schmidt. Actually, began again. I started playing with vacuum filters and medias, and so I'll go back and say another expertise I have is on filter medias. I designed a lot of the woven filter medias that are used on large automatic filter presses today.
It's a different kind of filtration now?
Well, the new filtration is all vacuum filtration.
Okay.
In 2013, I invented filters and medias. And the key objective for me, of course, is to outperform anything that exists, any technology that exists by a magnitude or more. And that's very important. That's how I'm driven. I want to make sure we're 10 times better than anybody else. And sounds like big numbers, but we've done it. But we were replacing conventional vacuum filters and filter presses. If you know what a filter press is, it's a pressure filter. But we outperform filter presses almost 2 orders of magnitude, maybe by 50 times or more. They're usually large, wieldy, have lots of filter area. And so that's our job, is of course to outperform anything that exists. I should add, in all important aspects, all pertinent parameters. In other words, efficiency of throughput, the amount of solids you get out, the amount of filtrate you get out, the dryness of the solids, the clarity of the filtrate. These things are all very, very important.
Got it. Got it. All right. So basically, I know the very basics of filtration, so you'll have to give me a little bit of a little bit more detail. What a pressure filter relies on, of course, pressure, but then it forces the liquid with whatever's in it that you're trying to filter out through a medium or a sieve, mechanical sieve. Is that correct?
That's a good concept. It's through a filter media, and the filter media is going to be specific to each individual application for the most part. My family and my background, I think, may be aware of my father, Hans Benessy, or my brother, Alan Benessy. They're all, my entire family, doctors, PhDs. I'm not. And my father was the youngest. He went to Princeton, and he was the youngest person and PhD to be selected for the Manhattan District, which became, of course, the Manhattan Project. And so he was at Princeton with Einstein, and they didn't know exactly what they were working on back then. But anyhow, that's the background. My family is a little bit more famous than I am.
Wow, that's something. That's something. That's a good story.
Yeah. There's a documentary right here. It's not released to the public yet. I'll show it to you personally.
Okay. All right.
Yeah. And so all my father's work is still classified to this day. It has never been unclassified, and it had to do with the isolation of U-235. And my father was in charge with the world's first plutonium. So at that time, 10 years ago, 15 years ago, 20 years ago, there were a lot of kidnappings. And the kidnappings were by North Korea and possibly other countries. But and so my father came. He was actually living here, Rupinder, in my home, when we made the documentary. But I'll have to show that to you. He's worked with many Nobel Prize winners, several Nobel Prize winners.
Did you ever bring Albert over to the house?
I met several Nobel Prize winners. I didn't meet them. I was very young when these guys got together. They would get together, and I just remember a bunch of guys getting together, men smoking pipes upside down and smoking cigars, and I didn't know who they were.
Back to filtration.
We're hands-on filtration trials and making these filter medias for UVF. It's thousands of trials, and it's ongoing, and it's material selections, hydrophilic, hydrophobic, the shape, the size, the match, and then what polymers are going to hold these particles together without interfering with some of the flow between the particles. So all that's enormous amount of effort. I was under pressure for minerals applications, particularly iron concentrate, gold leach material, copper concentrate, and tailings, the rejected product that come out of mining.
Customers for your filters and services are actually mining operations, and that's why you have your Brazil office.
Yes, Brazil and here in Utah, Canada, Colorado. And these are, in fact, some of the world's largest corporations. And so you can imagine the layers we have to go through.
Like Rio Tinto, that's Brazilian firm. And all of them are getting, would you say they're getting more concerned about not putting bad stuff into the earth and into the water? That's why
there's a very large disconnect there. The world has changed. The platforms, the systems that you have to go through, and you're going to find very few people, knowledgeable people at the ground level. There's too much of a divide, more of a divide, and so I think the opposite's happening. Unfortunately, there's a separation. Yes, and of course, at the ground level, I mean, you're going to get your hands dirty. You're going to be actually testing the material. You're going to be mixing it at different suspended solids. You're going to be using flocculants chemicals. All these things, to really learn at the base level what's going to perform, it's needed, and it's becoming rarer and rarer, unfortunately. And but luckily we've had we have a work study program, and we've had some young people, and oh God, they get so excited. It's refreshing to see that when they see what happens and comparative data, they get very excited. So That's something that's a little bit motivating.
But there must be a lot of regulation that demands that these mining companies filter out all the chemicals and the metals out of these tailings, right?
Yes, there's a lot of regulations, and there's an enormous public relations campaigns. But the unfortunate truth is that I think last year was the record number of injuries and deaths and this kind of thing from some of these installations. But you don't, of course, you'll never hear that or see that with any of the companies. So you have to be very, very careful.
Yeah. And I read about some of the mining disasters, but you don't hear so much about them, should I say, spoiling the environment as much as you hear about the dams that are breaking, because they make these dams out of earth dams to hold all the water, all the fluid, and they can break down very easily because they're not, they're just constructed with bulldozers, and they don't hold up well.
Yes, in Brazil, I lived near Brumadinho, and lost a couple friends in one of the dam failures. So actually, they were colleagues; they were engineers. The dam broke above an engineering house, unfortunately. So here's some key design features. First, the filter sector. It's all new proprietary technology. It has the highest throughput of filter media. Each has thousands of tests, obviously. It eliminates use of filter claws and has extremely low power, outperforms. That's the filter sector. I have two sectors in front of me. We're on the presentation. I was going to show you a sector. We can look at it later. I'll show you a sector that's been around for 5 years, and it performs as well as a new sector. So I have the new sector and the old sector here when we're ready. Cake discharge. UVF scrapes the cake, the filtered solids, directly from the surface of the filter media. And there's nobody else actually does that. So
so these can be unattended. They can operate for a long time without an operator.
Oh gosh, yeah.
Okay.
Oh, yeah. Definitely. They're continuous. They are not attended most of the time.
Okay.
And it's particularly difficult to filter materials. It's what they call slimes, and many of the tailings make thin little solids cakes. And the UVF is effective even on the thin little solids cakes, and very difficult to filter material. And then in order to keep the media going and cleaning and never plugging, we invented a two-phase pulse backwash system that it can be high pressure. And what that does, vacuuming, if you're running a vacuum filter where you're filtering material from a tank, and so you're going outside to into the vacuum, the two-phase backwash is pressure from the interior of the sectors to the outside. And so that pressure pulse cleans the filter media.
Okay.
And so that can be done without chemicals, and you do it right during the operation.
It says wash up to 10 B, capital B. What does that mean? 10 billion?
10 bar. That's about 150.
10 bar.
The UVF has the very highest throughput in the world and produces the lowest moisture of any vacuum filter in the world. And that it's more efficient, and you have less equipment. And so what happens, of course, is you also have the lowest cap OPEX, and capital equipment and operating expense.
Right.
And so one of the largest, I think it was the largest global engineering company in the world, actually did an extensive study with the UVF technology compared to other technologies. And their estimate, they estimated it's about 40% of the other filters. And I think that's wonderful. Thank you for your study. I think we actually do a little bit better than that. So, what the UVF does, it eliminates compressed air requirements, and you have a very small vacuum system. The vacuum system, the vacuum power, it takes a lot of power to run a large vacuum over a large area in a conventional vacuum filter. And so that's pretty much gone.
That's important because a lot of these operations are far from a good source of power, correct?
Yes, most of the minerals operations are, the majority of them are definitely remote. Often they're indigenous people, certainly isolated communities. And so that's exactly correct. And that's, of course, in the minerals industry. In the chemicals industries, not so much.
Sure.
And so very low water consumption, that has become very important. That's become particularly important today in dry areas, Australia, Chile, yeah, even the Mojave Desert. But the another advantage, it's very flexible and it works continuously. So you have continuous operation. And it's good for both what we call coarse particles and very difficult to filter fine particles. And so I see they put down here 4 millimeter solids, thick of solids, to 80 millimeters thick of solids. Also, it runs from 1 to 10 RPM. It has a variable frequency drive. Conventional vacuum filters are generally 1 RPM or 1/2 RPM. And the very maximum is about 1.5 or 2 RPM. But UVF goes up to 10 RPM. Okay. And so you have the best benefit.
What is the purpose of rotating?
Well, you have the scraper is fixed. What's scraping off the solid is fixed. Scraping off the solids is a fixed blade, and you're rotating around that fixed blade while the solids are being peeled off. So there's less process downtime for filter sector cleaning. Actually, as I said before, you don't really require any other cleaning. The very small amount of water. And here's a UVF versus vacuum disc. And of course, with our advantages, our filter media, much higher filtration rate, lower power consumption, and power consumption per ton basis. You make a lot more money with a UVF. Your profitability is up. And then the solids, the filtered solids, you have direct scraping. And so you have full removal of the solids, and there's no compressed air required. Just comparing it to a vacuum disc, which uses filter cloths, filtration rate is relatively low. Power consumption is quite high, actually, on a vacuum disc. And the cake discharge, they have what's called a snap blow. It's a blowback of the filter media. And they use a tremendous amount of water. The water is an exterior wash and a tire filter wash, and it requires a shutdown of the filter. And so the spray washing and so forth it's rather poor efficiency. And then the installation footprint is quite high because you're using 7 or 8 filters of a conventional vacuum disc filter per every 1 UVF, universal vacuum filter. And then the UVF produces clear filtrate, whereas the vacuum disc filter actually produces somewhat dirty filtrate. The largest company in Brazil, one of the largest companies, sent iron ore concentrate and tailings. And we're talking drums and drums right here in Novato. And then, of course, they flew up to watch and they did some comparative testing. And of course, you can see got much, much drier than the existing filter. And you can see the cake thickness difference. The throughput, 5 to 20 metric tons per hour per meter squared dry solids with a UVF versus 0.7 to 1 metric tons per hour per meter squared. So that's an enormous difference. With the tailings, UVF got up to 10 metric tons per hour dry solids. And the existing filter got roughly 4.4 metric tons per hour.
Got it. Now, these are rates, not volumes or quantity, right? So I imagine your neighbors would not be happy with you having metric tons of tailing.
These are rates. And I forgot, I think there was five 55-gallon drums of the concentrate and maybe 5 55-gallon drums of the coarse tailing.
Still quite a bit of material that you're handling.
There's nothing harmful or hazardous. And it's actually, believe it or not, this is a relatively small filter, the pilot filter. It's also very, very good. And we've successfully tested up to about 12,000 foot elevation, which has less vacuum. But UVF works fine.
Oh, good. Those tailings they're not going into Nevada Creek, or
we take the tailings to the disposal service. It's non-hazardous. It's garden waste. So here's a UVF filtration. Here's a pilot filter. This is actually a baby commercial filter. And it's designed this is on a skid. It's self-contained. Each disc has 12 sectors, and that disc, the filter area is about 0.3 meters squared with this unit.
By the way, what does FM stand for?
What it started out as, but we'll call it Filtration Masters. Filtration Masters would be a good.
Now tell me, where is this manufactured? Because you don't make that in the office here down the hall.
No. As a matter of fact, we support our local steel companies, our local fabrication companies, our local equipment companies. We try to support locals and keep folks going. And so the manufacturing, manufacture components. Right now, we have one little facility on the way to Mare Island. And going back in history with Pneumopress, Pneumopress was actually manufactured in the very largest shop in the entire Bay Area. It's in Napa. It was owned by Napa Pipe, but that was Pneumopress. Now we're building units again. And so we may end up either at Mare Island or a facility to the north. So that's going to be happening quickly, actually. So I'll keep going here.
All right, please.
Here we go. Here's an installation. This is a magnetite. This is iron concentrate, magnetite. And it's at Peña Colorado, and that's in Mexico. And you get to see the installation. And you see on the right, you see the filter operating, the scrapers discharging the cakes, and it's producing 10 or 20 times as much as anything on the plant there. So that was very interesting. Here's a live animation.
I see the scraper now.
Yes.
That's good to see that.
And the characteristics of the magnetite we put in because it's so fine. In this case, it's 84% passing 400 mesh, which is unusually fine. Blane is surface area per cubic centimeter. And so it has very high Blane. These are terms that are used in minerals.
Okay.
I'll keep going here. And this is data. We certainly don't need to go through all this data, but it shows the RPM, the vacuum, and the different production rates
Okay.
of a very difficult material.
Yeah.
And we were too efficient in some cases. Because we couldn't get our results back, we ended up taking a lot more water out of the solids than they wanted. But then when we adjusted, of course,
Yeah.
the production went way up.
Got it.
Okay, and here's the moisture range. It gives you a moisture range. The filters, the existing filters that they had there were getting above 10% moisture, well above 10% moisture. And that's the solids. And we started out getting the moisture too low, which no one had ever experienced before. And we finally brought it up to what their goal was 9.5%. And so when we brought it up, of course, the production went way, way up.
Okay.
So here's the gang at Pena, Colorado.
Those your employees?
Yes. Yeah, that's 1, 2, 3. There's 3 of us there. And then there's the client and then some engineers from ArcelorMittal and a couple other places. And they had flown all the way from Canada to come watch the installation. Quite common too.
Yes.
And so the key takeaways: slurry, fine magnetite, target moisture easily maintained. And target moisture, it's just the efficiency and bringing the moisture down to the desired level. And so that's the target moisture. The throughput range was several times as high as what existed, and then very low power consumption. And they're continuing with us. So those are the takeaways. And UVF reduces carbon dioxide, the emissions. Chemicals are not needed. You save up to 75% in any compressed air power consumption. And I see there's an error here, save up to 40% vacuum pump system. It's a lot more. You're saving a lot more than that. And of course, the study is 40% CapEx OpEx reduction. And again, you're saving a lot more than that. I think that's big numbers, but they're real numbers. There's well over 10, there might be 15 or even 18 patents on this new equipment. And here's, if you know what tailings are,
Yes.
Here, I'll do a tailings. Let's see if we can do a tailings.
Amazing, 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 amazing.
Yeah, those are filtered solids, and those are tailing solids. So you just won't see that anyplace.
I did want to ask you about all your patents, because a lot of our audience, they're design engineers, and they're often curious and want to know about how difficult that is.
There's some procedures you can go to, especially if they're new patentees. You can begin with a provisional patent application.
Okay.
And that's a short version. It doesn't get published, and you're only allowed, I've forgotten whether it's 12 months or 18 months to 12 months or 18 months to file what you call a utility application, a full professional application.
Okay.
And when you file, generally my patent attorneys always file with what you call the EPO, European Patent Office, and the PCT, Patent Cooperation Treaty. And when you file with them, you brace yourself, because in both cases, they publish your patent and allow, I think it's for 18 months. Don't keep me to this exact time, but they publish your patent for a considerable amount of time, seeing if anybody is going to raise a claim or contest the patent. That's part of the patent process today.
Okay.
And then you'll gradually, it'll be rejected. Most patents are rejected, to be frank with you. And
okay.
so,
what's your success rate?
I got 100%, but that doesn't mean 100%. The first go around, it may be fully rejected, and then you get a little letter from the patent examiner saying, we might consider this, or this kind of thing, and then you refile. So when you begin, you need to prepare for some of the responses that you get from the patent examiner. But over time, I guess I have 100% rate because you go after them, and you'll get continuation. You have to write office responses. And those are for the bigger, the PCT, Patent Cooperation Treaty, and EPO. Then, as soon as it's allowed, then it goes into the national phase. And then you actually are starting to get patents in the USA. It's placed in the USA. It's placed in Brazil. It's placed in Chile. It's placed in Germany. It's placed in Japan. And each of these national phase, you have patent folks in each nation. And
I would have thought you filed once for the EU, but that's not true, huh?
Oh gosh, no. No. It's EPU covers, or excuse me, the EPO, European Patent Office, covers a lot of the industrial countries, and then you have to designate which countries that you want to apply. And I just received allowance from Australia, just sitting around here somewhere.
Okay. Now you do it with a lawyer. Would you recommend that, or is it ever a case where an individual?
Yes, definitely get counsel. You might, if you don't have any money, if you don't have any money, you want to start a patent. You would want to write a provisional, and you'd want to have it witnessed and understood. In other words, you're going to have a signature, and you'll have a signature of another person who witnesses and understands. You can do that, and maybe you can get by without an attorney, at least through the provisional.
Okay. And a provision lasts, you said, a year or 18 months?
It's either a year or 18 months, and then you go right to the full utility patent. And I definitely recommend a lawyer for the utility patents. They're complex.
Is this also, it sounds time consuming. Is it also expensive?
Yes. The attorneys told me years ago, you're reaching a point where you're paying $250,000 a year in maintaining the patents. And it's the truth. That's what happens. We might even be over that. I don't know.
Okay. So you shouldn't waste it on every idea you have. You should save it for something that's commercially viable or potentially commercial.
Yes. On hindsight, I might have done some more things differently. Confidentiality agreements, solid confidentiality agreements, keep you going if you have the confidentiality agreements until you file the patent. And you can live with confidentiality agreements for a long time without having to file.
Tell me the full number again, or have you lost count, the number of patents you have?
I'm going to say between 35 and 40 patents.
That's impressive, Steve.
You'll have to walk 40 feet and come to my office and take a look at the walls.
You're quite the inventor.
Of course, I'm very old too.
But it's been great. Thank you so much for joining me and agreeing to be on the show.
Thank you, Rupner, for inviting me. It's been great. Thanks a lot.
All right. Appreciate it. All right. Have a good rest of the day. Bye.
Okay, you as well.
Bye-bye.
And that concludes this episode of the Masters of Technology Happy Hour. I hope you enjoyed our chat and will join me as we talk to some of the most interesting people in the design and engineering software community.